Good morning, everyone. It's Thursday, January 14th, 2021. We're here with Malcolm Blanchard. I'm Dag Spicer from the Computer History Museum. Malcolm, we're delighted to have you here. By the way, just before we start, is that a harpsichord behind you?
No, it's a baby grand piano.
Oh, a baby grand. Okay, I was wondering. That's very, very interesting looking. Well, usually, Malcolm, we like to begin our interview with the earliest years of your life to sort of get a measure of your whole career, not necessarily just where you work, but your whole life. So with that in mind, could you tell us a bit about maybe where you grew up and your parents, what they did, what your family was like, and those kind of things?
Okay. I was born in Oregon City, Oregon, which is at the end of the Oregon Trail. At the time, though, my parents were living in a little logging community up in the Coast Range of Oregon called Valsetz. My father worked in the forests, and my mother was a school teacher. And she demanded to give birth to me in Oregon City, so my father had a very long drive that night, I understand. And was born there. Later we moved to a town near Oregon City called Canby, and that's where I went to primary school there. And in 1959 we moved to Arcata in Humboldt County, California. And so that's really where I think where I grew up, because that was from about fourth grade on and through high school.
Right. And now, what kind of kid were you? Were you into science or sports or?
Not sports, science. Yeah, science and math were definitely the things that interested me. I have an uncle, and I had him at the time, who was very much into biology. He owned a company that provided specimens for educational institutions. So if you ever dissected a cat, he might have embalmed it. And so I was very interested in science and things like that, and he certainly encouraged it quite a bit.
That's wonderful. It often just takes one person, doesn't it?
Yeah. Interesting thing about it, my brother and I occasionally would, in the summer, go up and work with him in his lab. And in order to preserve all these specimens, they just use huge amounts of formaldehyde. And the lab was just awash in formaldehyde. So you would walk in, it would take about a week or two before you could get used to it enough that you wouldn't just be constantly crying as you went in. And I'm kind of amused that, everyone is so concerned about, breathing in formaldehyde this day. My uncle spent his whole life doing that. He is going to turn 102 in April. So maybe that preserved him.
Yes, perhaps it has a preservative after all, in living tissues.
Yeah.
Anyway, well, that's wonderful. And now you mentioned your brother, so just tell us about your siblings and
yeah.
what
I have
you
two.
have there.
I have two older brothers. One is 11 years older than I, and he didn't make the move to California. He stayed in Oregon and is still there with his family because he had just married before we moved. And then I have the next older brother is still in Arcata. And he's 4 years older than I am, 4 or 5.
Did they pursue the same kind of career as
No,
you, a technical career?
not at all. We're very different people in many ways. Actually, the middle brother ended up being a mortician for a lot of his life, and then was in selling insurance. And the oldest brother was a salesman for building supplies, windows and doors and things like that. But no, I was pretty much the nerd of the family, so I was interested in that.
Yeah. Now, I always ask people that were sort of came of age in the 1960s or so, what influences from the world at large might have played a role. For example, the space program, or the Vietnam War, or those kind of things.
Yeah, definitely. I was very much interested in the space program and followed that very closely. I even remember there was, I think at the time, Cheerios cereal boxes would have printed on the back a building that you could cut out and fold up and create a little building. So we had a whole space launch pad I had gotten from those cereal boxes, and you could send away for the a plastic model of the the Mercury space stuff. So that was very much involved in that. Vietnam didn't really play much of a part until college, but in high school it really didn't loom very large. So I was in high school from 1964 to 68. So that was kind of the beginning of all of that, but it wasn't as big a thing as it was later.
Right, and you were of the age where you could have been drafted quite easily.
Yes. Well, jumping ahead a little bit, I was the year I was eligible was the first year they had the lottery, so you could kind of have some idea of what was going to happen. And I think they announced them from the least likely to get picked to the most likely, as we were listening to on the TV or radio, wherever it was. And I missed the first few, and it turns out I was one of the first few which didn't get to, so it put me way at the end of the list, which I was very fortunate for that. So it was not, I didn't feel the pressure that I was, about to be drafted as soon as I got out of college, because I would still have educational deferment until then. But
right. Now with high school, you mentioned this was in Arcata?
Yes.
Okay. And you graduated in which year?
1968.
Oh, that's right. You mentioned that.
Yeah.
So what was going through your mind when you were in your last year and about career and the road ahead? Yeah,
well, I was very much, again, interested in science and math, and computers were just starting to, be around. I was also loved those, in the 1950s and early 60s, these science fiction movies that always would have this computer room with the tapes rolling and kind of on all the consoles were all kind of rounded off, and it was that looked really neat with lots of flashing lights and such. So in my senior year in high school, I was able to take a computer programming class at Humboldt State, which is now actually called Humboldt State University. It was Humboldt State College at the time, which is in Arcata. And so I learned to program in Fortran in my senior year using one of the 3 computers that were in the county. There was one at the college. The county administrators had a computer, and then there was some accounting firm a payroll company had the 3rd computer in all of the county.
Wow.
So,
was this a standalone machine or a timeshare system?
It was standalone. Yeah. We go in with punch cards and feed your deck in through the card reader. And there weren't that many people using it at the college because this was early on days and hadn't really boomed yet.
Yes. Any idea what machine it was?
Well, it was an IBM
1401, maybe?
I don't remember now.
Yeah, that was a pretty popular one.
It could have been.
Time. Or 360, possibly.
Yeah. No, it wasn't that big.
Yeah. Okay. Well, that's interesting. So you cut your teeth on some Fortran at a very early stage.
Yeah.
And tell us a bit more about that. What was it like learning Fortran in that environment?
I don't have too many.
Environment. Sorry.
Yeah. Well, those punch cards, that environment lasted all through my college years too. So it wasn't until out of college I got kind of away from the cards. I don't have too many memories of that. I know I just enjoyed it a lot. It was such a. I loved the logic of it, the formality, the formal logic and all of that. So that learned how to do some simple programming. Nothing very extensive. So that wasn't until I went into college. Somewhere in my senior year, I think my mother read an article in like the Saturday Review about this new college campus, a new UC campus in Santa Cruz. And it sounded very interesting to me. So that was kind of, I put my sights on getting into UC Santa Cruz. Unfortunately, and I eventually did, but I went down and I visited. I actually knew brother of a friend who was there, and I stayed in the dorms overnight and really got a good feel for it, and was very much looking forward to going there. They announced that they were eventually going to have a computer science department, but didn't have one quite yet when I showed up in my freshman year. David Huffman of Huffman Coding fame headed up the department. And at that time, I think he had some graduate students, but there was no undergraduate program in place yet. But they were planning it. And in fact, it started my sophomore year that they had a department. And then it was called Information and Computer Science. And that's why I ended up majoring in it.
Right. Now, in a way, you're kind of fortunate to be in on the first, it's kind of a blessing and a curse to be in the first year of a program, of a department, because the professors are also working through their thoughts and how to teach them. But how was the program overall for you? Do you feel, how did it prepare you for?
Oh, it was great. I absolutely, really loved it. And the nice thing about that too is that there were only, maybe 20, students in the program. As opposed to now, you go down there, thousands, I think, probably taking computer science classes. So, you knew the professors, knew them very well, and they knew us, and it was a very nice environment to be in.
And were there any specific areas of computer science that you gravitated towards at that early stage?
It wasn't until my senior year. I was essentially just taking all the basic classes in both programming and logic and such. Very much more on the software side rather than the hardware. There was a little bit of hardware going on there, but I didn't really delve into that much at all. Then in my senior year, a researcher from Bell Labs, Ken Knowlton, came and spent a sabbatical, a year sabbatical teaching at Santa Cruz. And this is when I first heard of computer graphics. I didn't realize that was a possibility until then. And that immediately clicked. That's what I wanted to do. I'm a pretty visual person, and that combined with computers was just perfect for me.
And Ken Knowlton, of course, is very famous and accomplished. A wonderful opportunity for you to learn from a real master.
Yeah, it was.
From Bell Labs, I guess.
Yeah, he was at Bell Labs then. And of course, the hardware for doing graphics was pretty primitive then. I think we had a pen plotter, and that was about it. You certainly weren't putting anything up on a CRT that looked like shaded graphics is today, or even, we didn't even have any sort of, real-time line drawing systems. It was, I think, a pen plotter, and that was about it. And also just using a printer, to do different kind of gray shades, but very, very coarse stuff. But I had the basic ideas down, I think. So my senior thesis, I wrote a program called Balls and Rod, in which I could input a definition of spheres, and it computed a line drawing view of the spheres intersecting and removing hidden lines and all that. And it was, for the time, I thought was pretty good.
Yes. And now this was for your bachelor's degree, is
yes,
that
correct?
Right. And so you graduated with a computer science degree from there, and you had this one course from Ken Knowlton, really. It was your exposure to computer graphics.
Right.
And now, so what were you thinking once you finished your degree, your bachelor's? What, should I go to grad school? Should I work? What were kind of...
it's definitely I was going to go to grad school. And in fact, the other great thing that Ken Knowlton did for me was that he showed me some pictures that had been done at the University of Utah. And this was the first time I'd ever seen, like shaded computer graphics, full color. Of course, at that time it was mostly polygons, And I said, wow, that's where I want to go. There's, this is, cutting edge computer graphics was happening there. So I also applied to, MIT and Stanford and Utah. At the time, Santa Cruz had a pass-fail system, so I didn't actually have a GPA, which I think kind of, unless you were a really standout, I think that kind of hurt a little bit at some of the graduate schools. So I didn't get into Stanford or MIT, but I was happily accepted at Utah and went out there.
One of the things about Utah that always intrigues me is how did it become this world center for computer graphics research?
Well, I don't have all the details, but my understanding is it started with Dave Evans. He was the chairman of the department, and he'd been at Berkeley, I think, before then, and was recruited to go to head up the department at Utah. And somehow, I don't know how he connected with Ivan Sutherland, but that was what did it as far as making the place a big computer graphics center. As you know, Ivan did Sketchpad early on at MIT, and so was one of the early pioneers in computer graphics. And so he came out to Utah. He had also been part of ARPA, Advanced Research Projects Agency, the Defense Department, and had a lot of contacts there and a lot of pull. I think he'd actually worked for him or worked there at some time. And he was able to get a huge, multi-year, very multi-million-dollar grant from ARPA to just do basic computer graphics research. There wasn't any, nothing was really, any goals that were set down from the Defense Department, but we had money, and that really got, I think, the ball rolling. Plus, we just had luckily there was the graduate students there were just phenomenal. They all kind of are what ended up being the people running the whole industry at some point. There was Ed Catmull there, who I ended, kind of latched onto that star over my career. But there was also Jim Clark, Bui Tuong Fong, who unfortunately died fairly young, but he was there from Fong Shading. You may recognize some of these names. Henri Garreau was there, and I'm sure I'm overlooking some people that I should mention, but just a phenomenal group of graduate students that were there and doing lots of good stuff.
Yes, it really is. It's an amazing. It's almost like the phrase Camelot comes to mind. You know? It's like this fertile, incredibly fertile period of a couple of decades that all this amazing stuff came out of. So okay, you're starting at Utah, and you must have met or chosen an advisor at some point? Discussed your goals?
Martin Newell ended up being my my advisor of the Utah teapot fame. In fact, I think I've drunk tea out of that was brewed in the Utah teapot. It was actually his home teapot that he just brought in and digitized, and so I knew about that a lot. And I actually started doing some hardware at Utah, which I hadn't done much previously. And my master's thesis was to design a clipping divider, and this was Jim Clark needed that for his PhD thesis, and so I worked very closely with Jim to design and build this piece of equipment. Now, a clipping divider was for a line drawing system, so the lines that were generated could be outside the frustum of the field of view of a camera, and so you need to have a device that figures out where those lines intersect with the edge of the field of view. That's the clipping part, so that you don't get numerical wraparound and stuff like that. And then the dividing part was that we were doing everything in homogeneous coordinates, that is 4-dimensional space, and then just before you displayed things, you have to do a division that projects it into a 3-dimensional space, so the 4 to the 3. So that was the thing I did. It was called the Alpha Clipper, and successfully designed and built that, and Jim used it in his for his thesis.
The notion of an alpha channel, does that?
No, this is not
the same.
Not the same thing. Yeah, this is. Why did we end up calling it? The algorithm we used, we had an alpha in it in the equation, and that's why we called it an alpha clipper. But no, the alpha channel came a few years later.
Shows you a little knowledge is a dangerous thing.
Yeah.
In my case. All right. Well, tell us about how long were you at Utah, and how did it go? What were some of the milestones you encountered on the way there?
I was there just a couple of years. Spent most of the time, designing the clipper. But took classes from Ivan Sutherland and seminars with Ivan and a lot of other professors there. Ivan is an interesting character. He's probably one of the smartest people I've ever met in my life, and I've met a lot of smart people. He was really incredible. A little arrogant about it, I think, too, but he still was, a good professor. I remember his trick was, by then, a lot of people wanted to sign up for computer graphics classes, and he taught an introductory class to computer graphics. And the first day of class, he would come in, he would write a matrix on the chalkboard and say, okay, please now invert this matrix, and hand it in. And that usually got rid of about half of the people that wanted to take the class, because the math scared them away. And then, so the classes got down to a smaller size, and he was a very good professor and able to teach us really well. The thing there is now we started to have a lot of equipment that obviously didn't have at Santa Cruz. So we had line drawing, real-time line drawing systems, for instance, and we had the ability to scan out a raster image onto Polaroid film, for instance. There was also equipment there to scan photographs into the computer, which there weren't very many places that could do that sort of thing at the time. So there was a lot of opportunities for picking up some low-hanging fruit. And so one of the projects I did in Ivan's seminar was to say, well, I could scan in a photograph and then combine that with a computer-generated shaded image, and that would be kind of a neat thing to do. And so that turned out to be, I think, the first time that anyone ever combined a digital image with a photographic background plate, which everybody does it all the time these days. So, but that was probably the first time it was ever done.
Wow, no, at some point we actually have in our exhibit on computer graphics, I think it's Ivan Sutherland's Volkswagen that got digitized.
Mm-hmm.
Was that relevant to your work in any way?
That had happened before I got there, but there were several data sets around that people used to do experiments on. The big thing that was area of research at the time was how to solve the hidden surface problem. That is, you have a full 3D representation of an object, but from a particular point of view, some of that is hidden, some of it's visible. And so there were a lot of creative ideas about how you do that. And that's what so there were these data sets that people were using in order to test their algorithms on. The teapot was particularly interesting one because it's an interesting geometry. There are places where there's kind of a singularity where everything comes to just like at the very top of the lid is kind of interesting geometry. And you have a handle, so you have this place with a hole, and it was just a way of testing out those algorithms. Interestingly enough, when at the time Ed Catmull came up with the idea of solving the problem by just having a memory buffer. So not only as you go through and start to generate these, the shade of each pixel that's on the screen, you also remember at what depth it was, what the z value was, and if you just store that in a memory, then when you come in to find another pixel that's going to go at the same spot from a different polygon, let's say, you just compare the z's and say, oh, well, the one that's closer that's the one you use, and that really bummed out Ivan because it turned out that was just the brute force method. It wasn't very elegant, and it worked really well. And that's pretty much what people, have used ever since, is the memory buffer. And I think shortly after I left Utah, he kind of didn't do computer graphics as much anymore. He just felt that brute force was a thing, and it wasn't elegant, and he wasn't interested.
Do you think, I'm curious how Sutherland raised this money, because typically, I know ARPA is very forward-looking, but there's often some kind of military application in mind. I wonder if maybe flight simulators were
definitely, yeah. And I
Yeah.
think they were already underway, because Dave Evans and Ivan Sutherland had their own company called Evans and Sutherland, which was a private company making and selling computer graphics equipment, and flight simulators were definitely some of the stuff that they did. So that was, I think that was what they were hoping, that things like that would happen. The other big application was ship design. The designing of a ship's hull is an interesting problem, and they were hoping that computer graphics would help in that endeavor, in which it has, I think. But day to day, there was no okay, you have to figure out this battlefield situation or some sort of equipment that we could use. It was just completely free form. The other interesting thing that was going on at Utah at the time was the ARPANET was just getting built, which is the precursor to today's internet. I can remember looking at, a couple of years ago, a complete map of the ARPANET. I think there were 11 nodes on it, and Utah was one of them. So I also was at the very beginning of that whole internet era, and I think I used it once to run a program remotely at Stanford. When I was doing that Alpha Clipper, it was wire wrap technology. I don't know if that means anything to you, but you would take individual chips and you would plug them into a socket, and there would be a pin sticking out the back of the socket. And the way you did the circuit was you would wrap a wire around that pin and connect it to some pin that's connected to another chip. So there was this whole problem of how you route all these signals and do the most efficient way of wrapping wires. And Stanford had a program that actually did that computing. So you could say, okay, I could describe the circuit, and then it would say, okay, well, you'd wrap this wire to that pin, this pin, and that pin, and it would come out. And that was the one time I think I actually used the ARPANET to run that program remotely.
I think if memory serves, Utah had an SDS 940, but I'm not 100% sure. Scientific data systems.
No, we had PDP. No, it's PDP 10s.
PDP 10. That's
yeah.
right.
There were two. There were two there. There was one that was timeshare, and you actually input through using a teletype. So it was a clunk, 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 clunk to actually type something in. And then the other one was single user. So we had, you could sign up and just go in and use.
That makes sense. Now that I have a feeling the wire wrap layout program you may have used was called Scald, SCALD, by Kurt Widows.
It could be. I have no idea.
Yeah, you only used it once, so why would you remember?
And that was 40 years ago, 45, something.
Yeah, it's quite famous, and the timeline is exactly right. It's SCALD. and Scald. But I'm curious where you picked up your hardware knowledge, because so far your education is pretty software focused.
It was at Utah. I took a couple of hardware classes there, and it's probably not fair for me to call myself a hardware designer, because I was more of a logic designer, and so I could, if I looked at I could figure out how to build things using, NAND gates and that sort of thing. But basic electricity baffles me. I wouldn't know where to put in a capacitor and a resistor and that sort of thing. But I could do a logic design, and that was pretty much the extent of my hardware abilities.
Right, and it's interesting how certain inflection points in the history of computing, the developments are themselves reliant on acquiring a new piece of hardware. So, for example, the frame buffer really transformed computer graphics, I think.
Completely,
right?
Yes.
Just that one piece of hardware, let alone all the other ones. So,
yeah.
Tell us a bit about what happened post-Utah. You're just graduating, and anything happening in the family front?
Let's see. Yes, I actually was married when I left. When I graduated from Santa Cruz, like 2 days later was our wedding, and so we headed off to Utah together. That was my first wife. That didn't last all that long, but anyway, I was married at the time. And I don't know much else to say about that. In my senior year, my last year at Utah, there was a vice president of a CAD/CAM company in Boston came through and talked to graduate students about possible job opportunities. And this was Fontaine Richardson of Applicon. So at some point I was getting really tired of being in school, and I was ready to go out and do stuff in the real world. And so I applied to Applicon and was hired, and went out. And this is when I don't get the dates quite right. This is probably 74, sometime around there. And they had a program that they were selling, which was typically was a 2D design program, and it was used mainly to lay out circuit boards and that sort of thing. But they hired me along to join a team that was working on a 3D design product, and so I went out and worked on that, doing 3D computer-aided design and computer-aided manufacturing. And that product was eventually successful and went out into the real world. About a year or so after I was there, they ended up hiring Ed Catmull from Utah. And he and I were sharing an office at Applicon. And gosh, it wasn't that long. It was within a week or two of him arriving. He got a call from New York Institute of Technology. They were wanting to set up a computer graphics lab, and they had found out about Ed. Backtrack a little bit here with the president of New York Institute of Technology. This, by the way, is a private commuter college out on Long Island, and academically is not very well known, not to be confused with Massachusetts Institute of Technology. New York Institute of Technology, a very different beast. Alex, for some reason, got very interested in animation, and he kind of thought of himself as he wanted to be the new Walt Disney. And in fact, he'd hired a group of old school cell animators and had them working on a feature called Tubby the Tuba. And he got into, once he realized what the old school technology was like, he realized why it wasn't being done much anymore, because that's really expensive to do all that handwork. And so he looked around and thought, well, maybe this computer graphics stuff might, help out with doing animated movies. So he somehow he found out about the University of Utah, went out there and essentially said, okay, I want to buy one of everything. And so he just, he bought frame buffers, he bought line drawing systems, he bought plotters, and just, all of this equipment. And then, kind of turned to the folks at Utah and said, well, who do I get to run this? And they said, well, you just missed your perfect guy. Ed Catmull just graduated. He's not here, but he would be perfect for this job. And indeed, that was Ed's ideal. From the very beginning, that was Ed's dream, was to make movies with computers. As he's always said, that he wanted to be an animator himself, but his artistic drawing skills were just not up to it. And so that was what got him interested in doing computer graphics. Was they thought, well, I can do that. I can do the computer stuff and the technical stuff, and then, but his dream was then to use that technology to make animated movies. So of course, when Ed got this phone call from New York Tech that says, hey, we're setting up, a computer graphics lab in order to do animated films, it was like, my God, this is, his dream come true job. And poor Ed had just come to Applicon like weeks before all this happened. Now, of course, I'm sitting here in the same office with Ed, and I'm overhearing this conversation and what's going on, and I go, gee, that sounds awfully interesting. Hey, Ed, you need some help? You need someone to come down with you? And he said, sure, come on down. So Ed went down and kind of got the lab started, and I followed about a month later and went down and started working at New York Tech. I believe.
Sorry, just before we dig into the New York Tech story, can you tell, for the benefit of the people reading and watching, what a frame buffer is and how much they cost back then?
Oh gosh,
I think that's quite impressive and gives you an idea of how rare these instruments were.
Yeah. Okay. A frame buffer is a memory that you can store a color for each spot on the screen in the memory, and then it will generate a video signal by scanning that through the memory and creating a video signal or driving a CRT or something like that. So it's a frame buffer. You can take a frame of film, for instance, or a image, and you can buffer it, put it into a memory, which of course we all carry those around in our pockets all the time now. But at the time, the only ones available, I think at the time, it was from Evans and Sutherland. Xerox PARC had sort of one also, and we'll get to the connection with Xerox PARC in a minute. But Dick Schaub had I think built a frame buffer there also, but that was wasn't commercially available. Yeah, so Evans and Sutherland had frame buffers that they would sell, and they were 512 by 512 pixels, and 8 bits per pixel. And I'm not going to get the numbers wrong, but they were very expensive. I mean, that kind of memory was just unheard of, because that's a lot of
like many tens of thousands of dollars.
Oh yes, yeah, many.
And by the way, didn't Alex Scher buy 3 of them, one for each of the 3 colors, the RGB?
Yes. I'm trying to remember, the 3 or 4. We were up to alpha channel yet. No, I think it was 3. Yeah. But that was about when the alpha channel started to come out. We'll talk about that also. But yeah, he bought 3 of them, and we were able to gang them together so we could have R, G, and B. Normally, what you do with an 8-bit one was you would go through a color map. So you would be able to have a total of 256 different colors in an image, and so you'd use the 8 bits to reference, go through a color map, but then create the RGB output. But then, so we actually had 3, so we could do it directly without a color map. Only place in the world at the time.
Okay, sorry to have interrupted there. Please continue.
Oh no, where was
your story? NYIT just setting up the lab.
Okay. Yeah. So Alex Schur was a very interesting guy. He wasn't afraid to obviously buy a lot of equipment, and he he just loved our little group. And as time went on over the years, at the end of the day, he would always stop by, our lab on the way home just to see what was going on. He had a little bit of a problem kind of accepting people that didn't have credentials. He wasn't very good at kind of, judging people on their own merits and trust himself, I think. And that was really apparent with some of the people that he had doing the conventional animation. I mean, there were some, good, solid people there, but, they weren't credentialed. Ed and I, had some credentials, and so he was willing to let us do our work. Very shortly after I showed up, I think I showed up in January, I believe it was in April, we got a knock on the door, and these two guys showed up wanting to know what was going on and if there was any possibility they could work with us. And this was Alvy Ray Smith and David DeFrancesco. They had been previously working at Xerox PARC with Dick Schaup and using his frame buffer. Alvy has a PhD and was well credentialed, and he was pursuing doing color computer graphics. This was kind of his interest in particular. And at the time, Xerox PARC was they were doing computer graphics stuff and starting to invent a lot of office stuff and how to hook computers together and network them in an office. And Xerox at some point, corporate said, well, there's no real future in color in the office, so we're not going to support this color research anymore. And so that was the end of Alvy and David's tenure there. They too ended up heading to Utah and saying, well, where can we find some work, or where can we do some more research? And again, they said, well, you really need to go to New York. There's this new lab that's just been set up, has lots of equipment. They bought everything that ENS sells, and you really should go talk to them. So they got in Alvy's car and drove cross country and showed up at our door and said, do you need some help? And Ed said, sure. Alvy was very much into doing paint systems, so drawing on a computer, that was kind of his specialty, and in color stuff. David was more of an interesting guy. He's a combination of an artist, and I think that was where his degree is actually in art as opposed to any technical thing. But he's very hands-on, knows how, he can rebuild cars. And he ended up, his specialty and throughout his career was to figure out how to put computer pictures onto film. So scanning devices and things like that, which were just not around, and technology for that was very young. And so he spent a lot of time in that realm. And Alex, as I said, had a hard time, judging people on his own. And David wasn't exactly, he didn't have the right credentials. But Alex allowed him to use the equipment, and he went off to the NEA, I think, in order to get a grant. And so he brought in grants to support himself, but he had access to the equipment. So that was the trade-off that was made there. And so that was the beginning of kind of New York Tech, which over the years, a lot of great stuff happened there. Other than the kind of the general idea that, eventually we're going to make animated films with this equipment, there really wasn't a real set plan to figure out how to do that, what exactly had to be done in order for that to happen. And so it was like Utah. It was just very open-ended. People could kind of decide, I'm going to go do this or I'm going to do that, and they were pretty much left on their own to do that.
So when Alex Shore said, nominally the idea of this lab was to create animated movies, but he didn't really give you any deadlines or
No.
milestones.
No.
Shoot for.
Yeah. Ed was started out, and I worked on this too, was trying to do an in-betweening program. So in conventional animation, the master animators will draw a pose that happens at frame 10, and then another pose that's at frame 15, and then they give those two frames to a junior animator who will then draw the in-betweens. So we'll do the transition from this pose to that pose. So that was kind of Ed's first idea was, well, maybe we could solve that problem using a computer. We could, scan in those two poses and then figure out what the in-betweens are. Turns out that's a real hard problem to do if you're working from just two-dimensional images. There was some work being done on that at the time in Canada with the Canadian Film Bureau.
Hunger.
Yes, yes. Ween, what was the other guy's name? There were two guys that did that.
Yeah.
And if you look at it, it's a really weird effect.
Yes.
Because the in-between is like, well, you have this recognizable image, and then it kind of goes jumbled up together and then ends up being this other recognizable image. And there was no sense that this really was, a smooth sort of, or didn't make any sense in between those two extremes. And we found that was the problem too. After a few years, we realized that you really needed to understand what those three-dimensional objects were in order to do anything intelligent in between.
It's interesting how he was modeling, kind of using the old ways of doing things modeling the old way of doing things,
yes,
rather than sometimes computers let you move away from the old way and come up with a completely new way. But I guess that's often your first step is to kind of look at the old way.
And I think you kind of want to understand that process to know where you can do it differently. It's definitely and it also makes it, I think, easier for people who, the professionals that are already doing it to move to the new technology. They will have some sort of bearing, they know where they are and what's going on. This has always been kind of a interesting thing in both at New York Tech and then later out here in California was we tended to scare the shit out of the conventional animators and people doing conventional effects work, because their fear was, the computers are just going to put us out of business. We're going to just take it over and we're not going to be able to do anything, rather than realizing that this is a tool for them to use to get the result that they want. And so I think, so one of the things of trying to do, model old ways of doing things is to kind of ease that transition and, not scare people so much.
I remember in another interview that you gave, speaking about EditDroid and how the editing timeline is actually reversed from the way nonlinear editors work today, because that's the way it was edited using film.
Yeah. So, we'll get to all that in a bit, I think.
Yeah, we'll get to that later. That's much later. But, it's just a little parallel, I thought.
Yeah. So let's see. At New York Tech, I was, helping Ed a little bit with his in-between program. One of the interesting things about Ed is how the process he goes through for programming, or did then. He hasn't done any programming in a very long time, I think. But he would write the whole program out on a legal pad, longhand, and he would go through and kind of debug it in his head and go back and change it. And so he had this big stack of legal pad papers with the program written on it. And then he'd go over to the computer, sit down, and start typing it all in, which is just a strange way of doing it. Of course, back then it wasn't all that easy to edit a program on a computer, because it was all hard type printouts. It wasn't a CRT, with being able to look at characters on a screen and going and move things around and edit it. So it was, I guess
Exactly.
it wasn't all that unusual.
When each edit cycle is like, 10 hours or
Yeah.
a day or whatever the turnaround is,
Yeah.
you start to pay more attention to your statements. I
Yeah.
think.
Yes, that's true. That's
Yeah.
true.
Oh, by the way, are you still using Fortran at NYIT? And
We were early on, excuse me, but that was one of the things that Alvy also brought with him. Was he walked in, we were using DOS, and this was the DEC operating system at the time, and we were doing Fortran. And Alvy said, "I'm not doing Fortran." And actually, Fortran, and I was actually doing some assembly code, getting really close to the hardware. But he was not going to have any of this Fortran stuff, and so he, I would have known from Xerox about this new operating system that came out of Bell Labs called Unix. And so very early on, we adopted Unix there and started programming in C. And we were one of the very first places, to do that.
yeah,
So that was another kind of a first for that lab.
that's really advanced for that time.
Yeah. Personally, I was also, since I was one person that hadn't had any sort of hardware experience, I was kind of in charge of whenever a new piece of equipment came in. I was the one that was kind of integrating it into the system, and I was the systems guy. And Alex was constantly buying stuff and dropping it on our door and saying, "Okay, here, see if you can use this."
Wow, it's kind of a nice problem to have.
It
though.
is, but it gets old after a while. But one of the pieces of equipment was a video disc, came out of Ampex, and I think they were using it in broadcast television for replays and things like that. But our idea was that if we could control it properly, if we could go in and drop a single frame at a time onto the disk, and then we'd be able to play it back. So it solves some of these problems of not having to do things in real time. You could actually record it that way. This device was so fragile, though, that it ended up just not working. It had record heads that were just very close to the surface, and any little dust or thing could cause the heads to crash into the disk, and it would ruin the disk. But I spent a lot of time building an interface for it, a hardware interface for it, so that we could try to use it. We got to that point, but it was just too fragile to deal with.
Sounds like the old hard disks of old.
Yeah.
When the head crashed, it turned into a lathe,
Yep.
basically.
Yes, exactly.
You lost everything.
Yeah. And as I recall at the time, we had hard disks. We were using them for data. These heads were even 10 times closer to the surface. So it was just ridiculously fragile to deal with. Let's see. Also, gosh, at that time, this was I think the last time I ever saw this. But I remember we bought some expanded memory for our computer. We were using PDP 11s there at the time. And we actually bought some core memory, real, honest-to-God core memory with little toruses, magnets with wires going through them. And I'm trying to remember what size it was. It was, it certainly wasn't anywhere near a megabyte. It was some sort of kilobytes of memory.
Right.
And I remember just seeing this, this frame with all of this wires and the core in it. So real core memory.
We have that almost exact board, I bet you, on display. It's from DEC also, and it's got the core in the middle, and it's surrounded by integrated circuits, as though this is the last stand for core, right, before the ICs take over.
Yeah.
But I know what you mean. It's fascinating, and you really wonder how on earth they thread those tiny little
Yeah.
things.
As I recall, they were their manufacturing plant was in Ireland, and they hired lace makers. So people that knew how to do lace work, and because it was that similar sort of precision and
Yeah,
was my memory.
interesting. So NYIT, I think around 1978, you start wanting to try something else?
Yes,
perhaps?
yes.
Yeah.
Well, as I said, it was a little unorganized for my taste at New York Tech. It was a big playpen, and I didn't really see us getting to the point of actually making a film there. I kind of felt a little frustrated with that. My wife at the time was also getting a little frustrated with New York and wanted to go back to Boston, to Massachusetts. And so, yeah, I guess that was in '78, around there. I decided, okay, I'm going to go back to Applicon and see what happens there. So at that time, then I left at that point and went back to Applicon. Let's see, New York Tech kind of continued on. Afterwards, Jim Clark came out and worked there for a little while.
Oh, didn't know that.
Yeah, and Jim Glen was there. Some names you may recognize. Yeah. And it was interesting. Professor Greenberg from Cornell, forgetting his first name, but he would every few months would bring a bunch of Cornell students down just to look at the lab and see what we were doing. It was so there was always a lot of interesting people coming in and out. But yeah, Jim Clark was there. Yeah, Jim got. Don't remember exactly what happened, but at some point he wrote a letter to somebody that was very critical of Alex Schur, and somehow that letter ended up on Alex's desk, and Jim got fired. So after that, Jim went to Stanford. Actually, I think he went to Santa Cruz first, but ended up at Stanford. And then as technology moved on, he ended up designing a graphics chip that was the basis of Silicon Graphics. And
the geometry engine.
Yeah, the geometry engine out there. So he claims that Alex firing him was one of the best things that ever happened to him in his life, because it set him out and got him going.
Seems to have worked out for him.
Yeah, that's for sure. Okay, so I'm back in Boston, working for Applicon. They're still down there doing their research. And at some point George Lucas out at Lucasfilm here in California was really getting frustrated with the old technology, with having to deal with film in particular. And he had the first Star Wars film had come out, so he had a lot of resources. Had his special effects lab, Industrial Light and Magic, ILM, in San Rafael. But he thought that there should be some new technology that could be applied to this filmmaking stuff. And actually, he's good friends with Francis Ford Coppola, who also was very much into technology. And so I think the two of them were really wanting to see if something could be done to improve this whole process. Yeah.
Sorry, do you know what part of the process in particular they were trying to improve? Like, was it the appearance of special effects or production process itself?
Production process itself. In particular, George did a lot of editing, film editing, which, at that time, the way you edited a film was you took the physical film, you cut it, cut another one next to it, put them together and put Scotch tape over them, essentially, fancy Scotch tape, but essentially just tape them together, and that's how you made your cuts. And if you want to change your mind, then you have to take the tape off, and you have to cut it in and all this. So it was a very frustrating process for him. And so that was his primary interest. He wanted to do, see if something could be done with the editing process. So anyway, he somehow heard about New York Tech, and Ed was then contacted saying, "You want to come out and set up a research group here at Lucasfilm?" And of course, at the time, Star Wars had just had been out, and they were working on the second one, the second Star Wars film, and so it was a high status place to be. And I think they were getting a little frustrated with Alex too, just that Alex just Alex didn't know how to make films, and Ed realized that in order to make films, you have to have some people that knew that industry and those techniques. And so he pretty much jumped at the chance to come out and set up the computer graphics lab at Lucasfilm. It's actually called the Computer Division, but we were to do kind of some research, applied research for the filmmaking. There were.
Can I just ask what the difference is between ILM and the Computer Division of Lucasfilm? How are they related, if at all?
Siblings, I would say, was kind of how that worked. There were several divisions at Lucasfilm. ILM was obviously the biggest and most prominent one. There was another division called Sprocket Systems, which was doing sound and film editing, was kind of their post-production stuff for doing that. Ben Burt was the big sound guy there, a guy who invented all those great sounds from the Star Wars movies. And there was also a division that was building George's Ranch out in Marin County. I don't know if you're familiar with that, but he has this beautiful big ranch with these gorgeous buildings that all beautifully designed with stained glass and beautiful redwood stuff. And at the time, that was being built. So there was a whole division that was in charge of building the ranch. Yeah, interestingly, when we first set up offices in Marin, we were in the same complex. Right next to us was the stained glass studio. So we could go over and watch them making all these beautiful windows that were going on. Let's see, how am I getting ahead of myself here? Anyway, so Ed then started kind of secretly recruiting other people to come out and do this work at Lucasfilm. And I heard through the grapevine that this was going on, that Ed was going to be setting up a lab at Lucasfilm of all places and working with George Lucas. And so I called up Ed and said, "I need some help." And he said, "Yeah, come on out, let's talk." And so that's how I kind of got back onto that train after spending a couple of years back in Boston. I ended up going there. And this time they actually had a plan. They had 3 projects that had real goals, and so that Ed was starting to learn managerial skills, and it was coming together. So the 3 projects were for George. He wanted to do editing, so that was kind of trying to put together some sort of a system that we could do the editing on a computer instead of having to cut pieces of film together. And that's what ended up being called EditDroid. There was another project for doing digital audio. And that was a big hardware design to kind of do a digital soundboard was going on. And then the third project was how to scan film in and out of the computer and do the blue screen techniques, or emulate the blue screen techniques. Doing compositing sort of stuff was the primary reason for that. So those are the 3 projects that were really well defined, had goals. Go out and try to figure out how to do it, design it, and build it.
About how many people were working at?
Well, obviously over time it changed.
Right now, about this time,
dozens. Well,
wow, very small.
Oh yeah. No, we were, the very first offices I was in, we were in what used to be a laundromat, and they'd fixed it up with some offices, and there was, I don't know, 20 people maybe max there. So yeah, it's a small group, but there, it's recruiting more people, and it did grow.
The funding was mainly from Star Wars.
Yeah, in fact,
profits.
Ed was hired and was doing a lot of the planning and such, and was not given the go-ahead to expand until after the second Star Wars film came out. And if that had been a flop, then that would have been the end of it. But it too was fabulously, successful, and so Ed was given the green light to go ahead and start all these projects. When I first went out there, though, and this is what you're saying was the connection between that and ILM, I worked on a smaller project, which was to build an asset management system for ILM. One of the things I did when I'd gone back to Applicon was work on database systems. And hadn't really done much with databases before then, but I kind of learned the techniques and how that stuff works. And so that was what Ed had me do, was to build an asset management system so they could keep track of all those little pieces of film that go around ILM, from the camera department through editorial and all of the effects stuff and compositing.
So I'm sorry, at this point you're literally tracking slices of film or canisters of film or what? What's the basic unit of...
The basic unit was a take.
Oh, okay.
So I think that was, because as it came out of the camera department off the stage, there would be this scene, this take, and keeping track of all those takes.
Oh, okay, thank you.
Yeah. So this was, again, this is fairly early on, and so we didn't buy a database management system. I wrote one. Spent some time writing one, which was it's a fun experience. And it worked pretty well. It certainly would not have scaled to anything like an Oracle would do these days, but it was up to the task of doing the asset management. So I built a general purpose database management system and then wrote an asset management system on top of that for ILM.
At this point, is that system actually handling digital files or just pointers to them?
Digital files. Of the film itself? No, it's pointing to pieces of film.
Okay, got it.
Yeah. So the records are it's this this shot, this take, and what other descriptions of it and whatever
Right. So you're in that transitional period between the assets themselves are not digital yet.
Correct. Yeah, they're very much all analog at that point. So that took me a year or so to kind of get that together, and they used it on some early films that I would just lie awake at night saying, "Oh God, don't crash, don't crash." Because this is.
Yeah, I think a lot of programmers have that syndrome.
Yeah.
So so that was the asset management thing. The two other things you mentioned were what became EditDroid and then the digital sound project. Mm-hmm. Could you tell us a bit about those two?
The digital sound project was headed up by Andy Moorer. I'm getting the names wrong. Anyway, a good sound guy who was, what was his name? Oh well, I'll think of it and let you know later.
We can fix it later. Yeah.
And so that was, to essentially do a soundboard. At the time, the soundboards were, in order to mix together multi-track soundtracks, it was all analog stuff up until then, and this was to be done as a digital one, which allows them to do a lot more audio effects and handle stuff. I really wasn't that close to that project, but saw it going on.
Were the audio files? I'm sorry. Was the audio itself in digital form for this?
It was digitized. The original stuff was still on tape.
Gotcha. Right.
And in fact, Ben Burt and his sound department, all that stuff was on tape.
Okay. What was I going to ask? Oh, did they interact at all with, like, say, Dolby or other people to actually improve the theater sound, the sound in the theater itself?
Yes, there was. That was a project that was also run out of Sprocket Systems, which was the sound and it ended up being called THX.
Oh yeah, right.
So at the time, and this was early on in early 1980s. If you went into a theater, the sound was arguably worse than what you would get if you were just listening to your stereo at home, because those systems were really using new technology and advancing and trying to improve with things like I guess with Dolby was used in that context also. But so George was very unhappy with the state of audio and also just projection going on in theaters. So they set up this a project in order to improve theater sound and projection, and that ended up being called THX, which was a bit of a pun. The guy who headed it up was Tom Holman, and one of the key pieces of equipment was a crossover circuit, which I don't know anything about, but so it was Tom Holman's crossover THX, but of course George's, one of his very first films was THX 1138, which was the name of it.
Right. Wow.
So,
wheels within wheels.
Yes.
That's fun. I like that.
So they essentially went out and designed, sound systems for theaters, and also set up standards for, projection. How bright does this image have to be on the screen and that sort of thing, and actually would go out and certify theaters and say they were THX compliant.
Okay.
Yeah.
There's a great scene in The Simpsons, by the way, where Grandpa Simpson is watching a movie and the THX thing comes on, the slow.
Oh, yeah.
And it gets louder and louder and louder. Finally, everyone's glasses in the theater break. And Grandpa Simpson says, "Turn it up, I can't hear it." Anyway.
Yeah.
Little moment. Okay.
That sound, by the way, was generated by the sound group in the computer division. That was a digitally created sound there.
Oh, definitely, very much so. The dynamic range is unbelievable. It really gives the speakers a workout, I'm sure.
Yeah.
In the theater. How about EditDroid now? That seems very significant, actually.
Yeah.
At least technically, I don't know how it did in the market, but it seems like a real important milestone.
Yeah. So that was one of the three main projects, and it was headed up by Ralph Guggenheim. Again, a lot of this stuff is they're starting to use technology that's not quite there, but they're trying to say, okay, I can see, a year from now the technology is going to be there, and then we can, really make this work. So at that time there were video discs were just coming out. That's a precursors to DVDs, or even compact discs were still not very much available. But he realized, they decided that the best way to go forward is to use that technology. They could record the film onto a disc or multiple discs, and then in real time switch between the different tracks on the different discs in order to play back and edit. So that was the basic concept, was to do that. But the technology wasn't quite there yet. Certainly video disc technology was just very much starting out and not quite there. So Ralph spent a lot of time for a year or so also doing a lot of research into what sort of video systems would be needed in order to support that. Also at this time they were trying to figure out what sort of computer hardware to use. there was a computer out of Carnegie Mellon or Pittsburgh called the PERQ, P-E-R-Q. That's what he started to use to begin with. Didn't work out all that well, and right about a year or so into that project, Stanford University Network Systems came out, Sun. So that was the origin of Sun, kind of built with the idea of Unix being run on it. So we became kind of one of the very first users of Sun computers. In fact, I believe one of our guys ported Unix to it. He was the one that actually put Unix onto a Sun for the first time. So anyway, they changed over and started using Sun, which was nice because it had a nice bitmap display, so you could do an interesting user interface, and that was, I think, one of the things that was really needed to be done. So after I'd kind of wrapped up my asset management system, Ralph asked me to come on and start working with the edit system. And in particular, since I had all this database stuff, I was kind of in charge of building a new scheme on top of my DBMS that was related to editing. So, would keep track of all the film and then the cuts so that we could, play them back properly. So that was one part of my task, and the other was to do the graphical user interface. So I was kind of in charge of how to do what to display to the editors. And I had no editing experience whatsoever. I mean, I knew nothing about this stuff. But there were some really good, nice editors who would, hold my hand and tell me, okay, here's what's that. And at one point it was, I'm already forgetting what the technical terms are, but there's a term for where you cut the sound before you cut the picture, in time, the sound changes before the picture changes. And it's like a split edit or something like that. And I didn't quite understand, they used the technical term, and I didn't quite understand what that was. And I said, well, what does that mean? And the editor actually took out a piece of paper and then drew, here's the picture going by, and here's the sound going by, and the cuts here on one, and the cuts here on the other. And that was my aha moment of saying, that's how how it's best to display the graphical user interface. So that was a timeline. And it was, ended up being, when I ended up implementing it, it was the first time a timeline had ever been implemented. So another one of my, being in the right place at the right time. I think people had talked about that before, but nobody had the displays that could actually support it.
I think that is an absolutely wonderful story. And tell us, I alluded to this before about the way that you go from right to left versus left to right. Yeah.
So again, we were trying to model things after what people were comfortable with. This also brings up another story. At the time, while I was trying to do this interface, it was thought that, I should go hang out with George for a while just to see how he works in the edit studio when he's editing. And so it was arranged, I was allowed to go in and sit there and watch George cut Return of the Jedi. And
oh my gosh.
I'm sitting in the room, his assistant is there, running into the other room and getting out pieces of film and bringing them back, fetching them, and he's, cutting them, going back and forth. Now, it turns out that it's really boring to watch because all the interesting stuff is going on in George's head, and it's not, you can't really see, that thought process. And George is a kind of quiet guy. He doesn't, he's not saying, well, I'm going to do this and then I'm going to do that and think of that. He just kind of, he's sitting there working away. And about a few hours into it, I'm realizing I am bored out of my skull sitting here. I am watching George Lucas cut Return of the Jedi. People would give body parts to be here, and I'm bored. It's like, get me out of here. So I only spent one day with George. But anyway, he was editing on a flatbed editing table. So that you'd have reels of film that kind of went through little thing that would project onto a screen. And in that setup, the film time went right to left rather than from left to right. And so EditDroid, the first iteration of it, our time flowed from the right to the left rather than what everybody else does. A year or so later, we decided, well, we can switch it back to do it. So
Wow.
it's a little more.
Was there any reason you switched back? Did anyone
I don't.
request that, or?
I think it was. I don't know that I was even there when they did that. At some point, someone,
Okay.
But of course, it's pretty much centric on our writing systems in the West. I mean, if we'd been in China, we probably would have, or if it had been Hebrew, it would have been going the other direction. Would have made sense too.
Yeah.
So.
Do you want to take just a little break, for a couple of minutes, or are you okay?
I'm doing fine.
Okay, great. I always like to ask.
Do
We've
you?
been going for an hour and a half, so just wanted to make sure you're okay.
Yeah.
Well, tell us about the state of computer graphics outside of Lucasfilm, which of course is this very unique sort of hothouse of the best and the brightest and the most advanced technology. What was happening in the outside world, in commercial or other uses of computer graphics?
Yeah. Let's see. At that time, the only other big computer graphics company I can remember was III, Image International, something or other. I don't remember what the whole I's were for. And they had a Cray computer, supercomputer at the time, and that was what they were doing their graphics, their work with. And there were a few, in research places and colleges and universities were doing some stuff, but it really wasn't, there weren't a lot of commercial stuff going on at the time. So as I said, one of the projects was the film scanning and in and out and doing compositing. That was kind of the graphics group in the division. And this was kind of Ed and Alvy's stealth operation in order to do computer graphics. Because George really wasn't interested in computer graphics. He was most interested in not having to cut and tape pieces of film together anymore.
Right.
But they were trying to do advance the state of computer graphics, knowing that eventually, when the hardware gets there, would be a good chance that they can make a film, a feature film. Let's see, where was I going there? So anyway, that's going on. One of the big problems at the time was emulating motion blur. Now, I don't know if you remember going back and looking at like stop motion films, like Harryhausen's stuff, Harryhausen.
Oh, yes.
If you look at it, it has a weird feel to it.
Definitely.
It's kind of static sort of image, and that's because each frame is perfectly in focus and clear. And in fact, in a real camera, what happens is the aperture opens for some period of time, and the scene continues to move. So if you look at each individual frame, there's a little bit of blurring there. Well, it turns out that you really need that for our eyes to make that look smooth.
How fascinating.
And the other thing I didn't know about this at the time, movie projectors actually display each frame twice. And so they're going at 24 frames per second, but if they just did 24 frames per second, that's a slow enough frequency that our eyes and brain will actually perceive that. You'll actually see that frequency. So they get over it by flicking it twice. So it's sort of like you're getting images now at 48 frames per second, and your eye then doesn't see that. But the problem is if you do a real sharp image that's here, but you're going to show it twice before it shows up here, your eye is tracking this object and you'll end up seeing two things going by. So it's another artifact of not having motion blur is you can get these weird weird artifacts. So anyway, the graphics group knew that that was one of the problems they really needed to solve was how to make images blurry, which was...
Yeah, you'd think that's the last thing you'd want to do, right?
Yeah. And in fact, when they finally did figure out a great technique for doing it, I can remember seeing a newspaper article saying, Lucasfilm figures out how to make blurry movies, blurry images. that was a big breakthrough. But yeah, there were several different competing ideas for how to do the motion blurs technique, and finally, stochastic sampling is what finally won out. So what that means is, if you want an image that's just a still image, you're going to go essentially look at your geometry and do a sample at each pixel, and you just do those all in a row, and that'll give you a nice sharp image. You also can get some aliasing, but we don't need to get into all of that stuff. But the technique was, instead of, if you have an object that's moving, for each pixel you actually dither the time that you're looking at. So the geometry actually for a particular image essentially is moving, because you end up sampling it at different times, and that creates the blur, and turns out to make it work really well. They also realized that other effects could happen, and that is you can use the same technique to do depth of field. So this same technique all of a sudden opened up the ability to really make images that looked like they were done with a real camera, and that was kind of the big breakthrough that group came up with.
Now, was there a point at which, I mean, I guess we're still there, but at which the uncanny valley in filmmaking became less horrible?
Oh, yeah. People at that time, we weren't even considering doing humans, really.
Okay.
That group got a few little effects jobs thrown at them from ILM. One of them was for young Sherlock Holmes, the stained glass man scene where
right.
In the movie there's a stained glass with a knight in it, and then the knight jumps out of the window, but he's just pieces of glass walking down through the church. So he's not trying to look like a real human. It's trying to look like pieces of glass, kind of in a stylized human form. Yeah, staying away from trying to do humans. So I should probably bring John Laster into the story about now, because he's also starting to be around the group.
Right, and I guess my last question brings up draws the distinction between animation and computer graphics.
Yeah.
And digital filmmaking as a third category, perhaps.
Yeah.
Yeah.
Later on, as we got into Pixar, they definitely try to stylize stuff. We're not trying to make it so that you think that's a real human, and then that kind of avoids that whole uncanny valley problem.
Right.
So in animation, it's usually stylized enough that it's not a problem. But
it's interesting, because in computer graphics, I've had several computer graphics people tell me that photorealism is the holy grail, right? But in some ways, I wonder if it really is.
Yeah.
Do you have any thoughts on that?
Well, it depends on what you're trying to do. As I recall, one of the mantras was that photorealism wasn't the goal, but that was a benchmark. That if you could do that, then you had the technology to do whatever. So it was more of a benchmark rather than a computationally algorithmic sort of benchmark to get to.
Right. That makes sense.
Yeah, and at this time, still computers weren't that, nowhere near the power that they are today, and so it still wasn't practical for the hardware to be able to make a feature-length film and of a high enough resolution that you could get away with it.
So are you basically workstation based at this time?
Yes.
Sun or Unix workstations, those kind of things.
Yeah, we at that time we were using VAXs. So we still had some DEC equipment.
Wow.
And yeah, there were both. We had both Suns and DEC stuff. Was what we were working on.
What you said earlier about the people behind some of these innovations that were sort of predicting the technology in a year or two would make these innovations even better. It reminds me of when you might remember Microsoft Windows first came out with a system that basically Bill Gates led this vision of wanting to make the PC your multimedia center so that it would handle audio and video. Mm-hmm. And it was quite poor at that, actually, the hardware, the first few years. And it makes me think, I guess he just saw a few years further down and thought, in 3 years we'll have sound cards that are better and video cards that are better and so on. And this ecosystem that I'm envisioning will actually make sense. Until then, it's kind of sucky.
Yeah.
But that's when you're on the bleeding edge. I guess that's what happens.
Yeah, and I along those lines, I remember at the time, at this Lucasfilm era, was when the Mac came out, the Macintosh, and and also the IBM PC were all kind of, and the folks at Lucasfilm Computer Division kind of poo-pooed them. It's like, these are toy computers. This isn't going to ever do anything very interesting, but that changed. Anyway, so the graphics group was trying to do all the foundation work for being able to make animated films, features, and there was going down. Let's go. What's happening off in the computer animation world, or the regular animation world at this time? Walt Disney was in a very deep slump as far as the films that it was making, and all the animators there were getting really old, and there weren't any new guys coming along, and so. Sorry,
what year is this, approximately?
Early '80s.
Okay, sorry to interrupt.
Yeah,
thank you.
Yeah, early '80s, so they realizing that they needed a new generation of animators. Disney funded CalArts to kind of train the next generation, and out of that group came a lot of really fabulous filmmakers. And one of the guys that was there was a guy named John Lasseter. Made some really great student films. Was hired by Disney to work for them as an animator. And John heard, knew about computer graphics, and so he wanted to try to start to, work with computer animation, and did a short, as I recall, that involved some computer animation. Did not go over well with the old crew at Disney, and so when his project was done, they just kind of let him go. Alvy and Ed somehow knew of John Lasseter, I think probably from his student film days that he'd put out. And so when Disney fired him, they contacted John and hired him on at Lucasfilm. Now, George was not at all interested in doing computer or animated films of any kind. And so it was a little problematic to hire an animator. And so John's title was user interface designer. So it was his official job was to kind of evaluate and do these user interfaces and kind of help improve them. So that was what John's official position was. What he actually was doing was starting to make short films in the back room. And the first one that came out was The Adventures of Andre and Wally B, which is very early on. And it got to be, for a while there, every year there's a big computer graphics convention called SIGGRAPH, and where all the computer graphics people in the world kind of get together and do a trade show and do papers and stuff like that. And so we tried to do a short film for a new one for each SIGGRAPH. And yeah, Andre Nwalibi was the first one. I think that the second one was Luxo Jr. And Luxo Jr. was a real breakthrough. Because up until then, a lot of these films, they had a lot of interesting technical content, and people would go at SIGGRAPH and say, "Oh, how did you do that? And what was this technique?" And nobody was actually looking at the films and enjoying them as pieces of, as film.
As stories.
As stories.
Yeah. Right.
And that was, with Luxo Jr., for those of you who haven't seen it, it's the Luxo table lamp that is now Pixar's logo. But it comes there. It's an adult lamp and a infant or child lamp, kind of playing with the ball back and forth. And there's a little story there, and it's really quite cute. But it was like the first time that people looked at it and said, "Oh, that's a story." And John tells after one of the screenings at SIGGRAPH, he saw Jim Glen, who was one of the pioneers in computer graphics, kind of heading for John, and John was going, "Oh God, he's going to ask me how what the technique was, what was the algorithm you used, and how did you do this and that." And Jim's question was that a father lamp or a mama lamp? And so the whole thing was, he was just bought into the story and didn't really care about the technology. And that was kind of a real breakthrough moment, I think, for the group.
For the whole company, perhaps.
Yeah.
They realized it's about the story, not the technology.
Yeah.
I'm sure they knew that anyway, but this drove it home. Yeah.
Let's see, and then I think the one after that was Tin Toy, which, and now we're getting into the uncanny valley again. This is the one with the baby. And it was probably the closest, at that time, it was the closest we'd come to trying to do a human character. And it was pretty uncanny, I think, but that was...
The classic one with the uncanny valley is that one, the Christmas Story with the train and Tom Cruise.
Oh, yeah.
I forget but that's held up as the exemplar of creepy faces.
Yeah.
And you really got to try hard to make Tom Hanks look creepy, but somehow they managed. Anyway, let's see.
So where are we here in the story?
Oh, yeah.
So we're getting along. We're able to emulate a lot of the analog stuff using digital techniques. The EditDroid is coming along and is being commercialized, and the soundboard was it was kind of getting to the time where we needed new projects, or where are we going from here? We pretty much can see the end of the road for those three projects. So at about that time, George and his wife divorced. And so George, all of a sudden, in order to keep control of Lucasfilm, essentially needs to raise half the value of Lucasfilm in cash. And so...
because he had to pay the other half to his ex-wife.
His ex-wife, yeah.
Right.
Okay. So, and we were kind of finishing up our project, so the decision was that Lucasfilm was going to sell the computer division. It actually ended up getting split into two parts, one of which did EditDroid and the sound system, which is called SoundDroid, and then the graphics group was going to go out and try to do some computer stuff, computer graphic stuff. One of the other things that happened with the computer group was the design of the Pixar image computer. This is where the name Pixar originally comes in. In order to do the compositing of, multiple frames and layers, you needed to have a computer that really understood frame buffers and could deal with them very quickly and combine them properly. And so they designed some special purpose equipment called Pixar Image Computer. And so the idea was that the computer division would go off and try to sell that as a product.
What would you call that? Beyond, I mean, in generic terms, is it like an image processor?
It is, yeah. It is essentially, it's a completely computer programmable, a programmable computer, but it's, yeah, it was an image processor.
Okay, because I noticed some customers were like dealing with X-rays. And,
Yep.
Yeah. Anyway, please go ahead.
Yeah, one of the main things about it was it could deal with like the 3 channels simultaneously. So it was single instruction, multiple data sort of architecture. But it could do a lot of different image processing tasks since it was programmable. So the decision to sell was made, and then we had to go find a buyer. And so a long process ensued there. Early on, Steve Jobs was still head of Apple, hadn't been kicked out yet, and he came by to kind of look at us and see, well, does this make sense for Apple to get involved with this? And I can remember, now I'd heard stories about Steve Jobs and I was kind of curious, what's this guy like? And so I knew this meeting was going to happen, that he was going to show up, turns out with Alan Kay was with him. And so I said, hey, Ed, mind if I sit in on the meeting? I just kind of like to see what this guy is like. And so I said, well, come on in. So I ended up sitting in on the meeting where, Steve first met Ed. And it was kind of interesting because I could, Steve, I could see, he sat down in the room and he immediately was scanning the room to see who's important, who isn't important. He looked at me, not important. And
oh, nice.
Well, he didn't say it out loud, but that was...
Such a warm fellow.
Yeah. Well, we can talk about Steve's life arc.
Yes.
He was definitely at one of the lower points at that time of his life. Anyway, so he looked at it and he was very impressed with the technology because we were doing color graphics at the time, and he was still just doing black and white, gray shade scale stuff. And so he thought this would be a good group to, kind of introduce color to Apple. We had heard all the bad stories about Bad Steve, and were a little wary of, working for him. That combined with, not necessarily wanting to be buried into, the big Apple corporation, Ed turned him down essentially. He said he's going to he'd buy us and bring us into Apple, and we said no. And going on, there was we talked to lots of people. General Motors was interested in being able to display car designs because they're part of their design process is that they have to build, a mock-up of what their design is and take it into a special room with all this lighting so that they can evaluate exactly what it looks like. And they thought, well, maybe we could use this technology to replace that.
So it's the image computer that is the main attraction for
that's
potential suitors?
Yeah, that's what we're selling.
Okay.
Yeah, it was kind of weird in that since it really was an image processing piece of equipment, we managed to port our rendering software onto it, so we could actually have it generate images too. So they could have used that.
That's RenderMan?
Yes.
And let me know when you want to talk about that, when the right time to talk about RenderMan is, because that's a major.
Yeah. That's more after we finally did become Pixar, is what we probably should talk about there.
Yeah.
So there was General Motors, there was the medical imaging. So Philips wanted to, and we actually did. That was one place where we actually sold some stuff. eventually. This, you know, it was, we didn't sell it until after we had spun off, but we were starting to talk to them and kind of understand how they could use for medical imaging. Prepress is another area where you could, you know, lay out color graphics and stuff like that. So we had prepress companies come in, which is another interesting story. All through this time, while we're, you know, looking for suitors, we're also, you know, a lot of George's friends, you know, would come in, you know, to see what all this new technology was about. And so we were giving demos to, you know, lots of people. And there was one day, and I gave a lot of the demos, because I did a lot of work with our trade shows and things like that, putting together the demos for that. But there was one day where I think in the morning I was to give a demo to one of the oldest, straightest printing companies in the world. It's a British printing company. They print about half of the world's currencies, so they're, you know, really proper and old and hairy. And in the afternoon, I was giving a demo to Jerry Garcia and Mickey Hart from the Grateful Dead.
That's great.
I just remember getting up that morning and saying, "What the hell do I wear to work today?" So the answer was I took a change of clothes and I wore a suit in the morning and t-shirt in the afternoon. So
that sounds like the right approach. That's funny.
Yeah.
And so these Hollywood types, I guess, and
oh yeah,
the beautiful people would come into your any other interesting interactions with or people that you saw?
Oh yeah. Who did Rambo?
Sylvester
Stallone. Yeah, he came through one day, and that was in particularly interesting to see him. This was when I was, I think this was early on, more when we were still working on EditDroid, and he was very interested in, you know, seeing editing stuff like that. But, you know, he shows up with, you know, beautiful blonde on both arms, and we sat down and we gave him the demo of the editing system, and he was, you know, really kind of contemptuous. I mean, he was obviously, I'm the big shot, blah, 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 and not very warm. And then George walked into the room and started talking to him, and all of a sudden the whole dynamic changed. He became completely subservient to George, and it was just kind of a funny little exchange to kind of see his personality and
see people's true colors.
Yeah. There were a lot of different stars come through.
Did you have the feeling this was more PR, or were any of these people, were they just kicking the tires, or was anyone actually going to buy any?
Well, you know, a lot of this was just George showing off his technology. But that was happening at the same time as we were trying to find real suitors to buy it. So we gave lots of demos and went out and tried to get people convinced to it. So that went on for about a year, that whole process.
Can I ask how you demonstrated the Pixar computer, or did you
just
show slides, or? No,
we had, especially at trade shows, we'd have, you know, real equipment there and would show things. I mean, one of the things it could do was it could do compositing in real time. So we could do some really fancy, of course these days you wouldn't think it's very fancy, but, you know, we could do some really interesting real-time graphics that nobody else was able to do at the time. Which also reminds me another thing about John Lasseter. This is when I kind of really got John as to what he was all about. One of our trade shows, we'd done a very photorealistic image of a road, and it was called Road to Point Reyes.
I know that well. Famous image.
Yeah, famous image. And the idea at the trade show was that, you know, we'd show this beautiful image that we could display, which a lot of people couldn't even just display it. But then we could show how that we could do some actually generate an image, and then also be able to overlay subsequent frames quickly enough that we could actually get an animation. So my idea was, we would, at the time, one of our shorts was of a unicycle, had a unicycle in it. And so the demo was going to be, okay, you can render this image of the unicycle, and we do that in real time. You actually see the image of a single unicycle. And then I said, and if you do multiple frames, then you can get an animation. And I wanted then just to have the unicycle kind of turn around and go down the road, point raise, and around the hill in the back. And so I approached John and I said, could you do that animation for me? It's just, all you need to do is turn the unicycle around and have it go down the road. Of course, John's an animator. That wasn't good enough. He had the unicycle turn around and have an attitude. And how he managed to have that unicycle do an attitude, and I went down the road, and it was like,
that's awesome.
Oh, I get it. And so that's the one time in my life that I directed John Lasseter.
Oh, that's wonderful. Tell us a bit more about him, and also Brad Bird, if you can. The storytellers.
Yeah, well, Brad Bird doesn't show up until well into the Pixar days.
Oh, okay.
But he's another CalArts alumnus. So, good guys there. Okay, so in that year I was trying to sell the company. Steve Jobs had been kicked out of Apple and was kind of figuring out what to do next. And he came back and approached us a second time. And either he was being nicer or we were getting more desperate. But this time we said yes. And so he...
what year was that?
You're going to have to check me on this. This is mid-'80s.
Okay. I guess we could look it up.
Yeah.
But mid-'80s, okay.
Yeah. I'm terrible at years, names, and things. So he, pulled out his checkbook and wrote a check to Lucasfilm and wrote a check to fund this new company called Pixar. And at that time, we had a product that we could sell through Philips for doing medical imaging. And then also we sold, ones and twos of the image computer to people doing research and stuff like that. So
at this stage, was Steve Jobs interested in what was Ed's motivation, which was to make movies using computers?
I think so. He certainly came to be. I can't remember. I think he was really more interested in the technology at that time. Was kind of his. He thought this was really cool technology, rather than he didn't want to. He wasn't dreaming to be a filmmaker.
Okay. Yeah, it's a bit of a leap in his case, but not in Ed's case though.
No.
It sounds like that was his overriding vision.
Oh, yeah, absolutely. From Utah days onward, that's always been
right.
Ed's goal. So we spun off trying to sell an image computer. It never made money. Steve, kept having to write more and more checks, but he kept writing them. And, we were all going to go, one morning he's just going to wake up and look in the mirror and say, what the hell am I doing? This isn't, I'm not going to get any money out of this, and this is just not happening. But he stuck through for quite a few years, just funding it, trying to get the image computer to work. And then by now, early on in Pixar was when RenderMan happened. So that's our, kind of photorealistic rendering software that, takes a geometric description of a scene and creates a very realistic looking image of it. That's another little pun. It was originally called Renders Everything You Ever Saw, which acronym is RAISE, and so the road to point raise was also a pun on that.
Can I just ask, what kind of person would use this software? What kind of professional would use RenderMan?
Well, at the time, special effects were starting to be done with digitally. So, and there was a lot of flying logos out there. I don't know if you remember that era on television where You know, you take your logo, extrude it, and then have it fly through space and tumble, and so it's flying.
Also, don't forget the era of chrome balls on chessboards.
Oh yeah, all that stuff. So yeah, a lot of people doing those commercials and.
Right.
Oh, that's another thing. When Pixar started out, there was a small group that was doing commercials for hire. So using RenderMan, and Ralph Guggenheim headed up that group. And they did quite a few commercials that ended up on TV at the
Did
time.
RenderMan render humans or just objects?
Oh, well, if you could describe the geometry of a human, yeah, it would. But it's
Okay. But it wasn't
it's a generic.
optimized for that,
No.
so to speak?
No. It was optimized. One of the optimizations was to be able to do some very convincing surfaces, and one of the things about it was there was actually a shading language, so you could program what the texture on a surface was, or if it has bump maps, or but it gave a lot of flexibility in what objects would look like, and obviously optimized for scalability, because people were kind of trying to guess, well, how many polygons do you have to render in order to have it look like a realistic scene, and
Exactly.
and it's a huge number, and so there was a lot of thought going into, well, how to make this algorithm scalable, and those are kind of the issues that were going on there.
So the typical person using RenderMan would be an animator then? Or something else?
No, more technical, I think, than that.
Oh, really?
Yeah, because it's
Not so much an artistic, creative type,
no,
but
yeah.
okay.
You would. The idea was, in fact, RenderMan itself is an interface specification. It was kind of conceived like PostScript was a specification for how computers can talk to laser printers. RenderMan itself is a specification of how some design program can talk to a renderer, and so that's what RenderMan is. It's a specification. The software, our renderer, was called photorealistic RenderMan. So it was our version of the thing that's on the back end. But the RenderMan interface itself was essentially open source. It was anyone could use it. In fact, we kind of encouraged that because we wanted that flexibility to be able to plug stuff in on either side of that interface.
Get people using it.
Yeah. So you needed to be pretty technical to use it. Although, let's see, I don't remember exactly what. There obviously was an animation system that we had developed first at Lucasfilm and then as Pixar. Obviously John Lasseter is not a technical guy, but he was able to use that, and animators, as they were hired on, were able to use. That's right. Trying to remember the name of it. It had some silly name, but anyway, we did have an animation system that was only used in-house, and so if other people were using RenderMan, they had their own animation system to drive it.
Right, and on the human side, when you're bringing people along to use these tools, Pixar must have had an internal kind of educational function, right, to train people how to use these tools.
Once Pixar finally got on its feet, we actually had a division called Pixar University, which was just for that. But that was quite a bit later. I think this was more one-on-one sort of thing. You got hired, somebody sat down with you and showed you the ropes and how to do it.
Okay. What's the head count these days, now that Pixar is an official company?
I think it was around 40 people were there when we left Lucasfilm.
Wow.
And
Still very small.
Yeah.
I believe people that were not in the computer graphics part of Lucasfilm got let go. Is that?
Well, there was another company spun off called the DroidWorks, and they were specifically supporting EditDroid and SoundDroid. And there also in that, and somewhere in there was a games division that was started up. That was kind of late in the tenure there, and they, I believe, stayed with Lucasfilm and did some games that were sold. But yeah, nobody. I don't know. It wasn't an explicit layoff. It was until later.
Yeah, exactly. One of the great questions from, or great answers actually, from an earlier interview you gave when they asked, how did Pixar become an animation company? And you said, everything else just kind of fell away.
That's essentially it.
Could you elaborate on that a bit for us? How Pixar became an animation company?
Yeah, so in the, we had this group that was doing ads, computer graphic ads. That was a very small group of people. It was, half a dozen people maybe doing that. And then the main focus early on was to the Pixar image computer, and at some point, it was clear that wasn't working. And so I believe that got sold to somebody else, and I don't remember all the details, but that technology, so that fell away. And we were still, on the software side, we're doing photorealistic RenderMan, trying to, we were selling that for other people to use and licensing it. Trying to build some products on top of it ourselves. One of them was Typistry, which was a system that you could buy commercially that would do your flying logos with RenderMan. So that was a product we tried to sell. At one point, had a really ill-conceived product called Showplace, which was essentially, I think it's supposed to be equivalent to a page layout program for graphics. So you would have canned models that you could, place in a scene and take pictures of. And I actually was the manager of that group for a while. But then it was, that stuff wasn't paying the bills.
The typical customer would have been like TV stations or people doing networks, doing their own logos, like that? Or?
There were actually more third-party companies that were networks and TV stations would hire to do an ad for them.
I got you.
Like our Greenberg was one of them, like ad agencies and people like that.
Right. Okay.
They were the primary customer. So this, wasn't going all that well, and so there was one very successful thing that happened here, also using the image computer, and that was a system that we built and designed and built for Disney, called CAPS.
Oh, right.
Computer-aided something system. I don't know. Yeah.
Production,
probably something like that. But up until then, the cells, individual frames, of a film, of an animation, were drawn on acetate and in a black outline. People would go in and paint the colors inside the black lines by hand. They would then all be sandwiched together on an animation camera stand and photographed. And that was the process. So they needed to do the painting and the compositing. And it turns out these are good things. These are things that the image computer can do very well. And so we hired a few people to kind of work with Disney and do the system, which did scanning and painting and compositing. So at that point then, it actually improved things by a tremendous amount as far as animation was concerned. If you think about it, when you combine those cells, there's clear, like one on top will be clear, so you can see some other color that's underneath, and on the other, it might be like two characters. One right. Character would be on one level, and another character there. But there was a limit to the number that you could stack because the film is not perfectly transparent. Each time right. You put it on top, and in fact, they would have, for a character, there would be a particular color of its shirt Well, there would be like 4 different versions of that color depending on which layer you were on. So if you're on the top one, it's probably duller than the second one. It had to be brighter so it matched on the top. Well, once you digitize this stuff and paint them and do it electronically, that limitation goes away. So you can have infinitely deep stacks of animation. So that helped a lot. Plus just the tedium involved in hand painting all those cells. So that was a successful product that we sold to Disney.
That actually makes me think that clearly there must have been like an edge detection algorithm in the Pixar image computer or something. Did it have its own language or its own set of commands?
Yeah, it was programmable, and it essentially had its own language, but it was programmable.
Yeah, that makes sense.
I think we might have ported C to it, but if you really wanted to get the speed, you had to be kind of a little closer to the hardware to really make it work well. So
right.
Yeah, so that was how, once again, Disney kind of shows up on Pixar's radar, and about the time that all this stuff was falling away, Disney came to Pixar and said, "We want you to do a film." And the original idea was, Ed said, "Well, we could do like a half-hour special." And Disney said, "Look, if you can do a half hour, you can do a 2 hour, or you can do a 90-minute feature. So why don't you try doing that?"
Which is completely untrue, I'm sure, right? It's probably 1,000 times more difficult. But anyway.
Anyway, yeah. So that was Disney came to Pixar and said that all this other stuff wasn't working out very well, and so this is when the company bifurcated, essentially. The whole group that was doing, software stuff, typistry and the showplace and all of that, kind of was, well, in that case, was laid off. We tried to regroup and start another company, but that didn't happen. But we're laid off. And meanwhile, the group that had been doing the commercials work started, ramping up to be able to do this film for Disney. People were, given the opportunity to join on. I could have joined the graphics group, but by then I was kind of burned out. time to take a rest. And so at that point, I left Pixar again, or left this group again, and it was at Pixar then. So the Pixar remained and worked on what would become Toy Story. And that took them quite a few years, and I don't know all the details because I wasn't there, just kind of saw it from afar, but that was when they finally...
And this is, I think, 1991 when you left the company?
Yes, that sounds right, yeah.
Right.
And then Toy Story came out in 95, something like that, so it was like 4 years that they were doing that. I went off to work for a company up here in Santa Rosa, Island Graphics, and they were mainly doing pre-press work and had a big contract with Japanese printing company Dai Nippon Press. And so I started, most of my work there was dealing with color issues. As you know, if you look at a color on a computer screen and then just print that out on a printer without thinking about it very hard, you'll get a completely different color. And so it was a difficult problem in order to be able to say, okay, what I'm seeing on the screen is what I'm going to get on the paper. And so I did a lot of work on that sort of thing.
That was a really gnarly problem. I remember, I forget what terminal manufacturer it was, but they actually came with a colorimeter.
That was Rob Cook's company, and what's the name of that company?
You put it on the screen and
he had
calibrate it.
Yeah, he had a whole, in fact, after a while at Island Graphics, I left there and just became a consultant, and I worked for that company for a while.
Oh.
And also for Broderbund and some stuff for Pixar. So I kind of independent contractor for a while.
So without getting too much into the hairy details, how do you match what's on the screen with what's the printed output?
Yeah, I ended up doing the same thing for Pixar just before I went back to work for them, but this is why I was a consultant. You essentially, again, it's almost a brute force method. They're very precise color coordinates called CIE coordinates, so that really define a color. And so what you essentially do is you look at the full gamut of colors that can go on a screen, and you record what the CIE coordinates are for each of those. So you kind of have a standard for, I know what that color is now. And you essentially do the same thing for paper. You know, you print out all the stuff all the colors you can on the printer, figure out what those are, and then you just do a match. You say, oh, on a screen I get this is CIE.
Transformation matrix that takes place, and things are mapped onto.
Yeah, I know I want this color in CIE coordinates. I know I can look up in a table, it'll get me that over here and there. Now it's a little more gnarly than that, because the actual gamuts on the screen are different than the gamuts on film. So for instance, there are some greens that you cannot show on a TV, on a CRT, but you can get on film. And so you kind of have to think, well, how do I deal with that? And so there are a lot of subtle issues in how that all works.
Right, and now you work in that area for Pixar. I think that was called the Chameleon Project?
Yes.
So it's pretty obvious to see what their application would have been. It's important they have fidelity on the screen.
And the interesting thing about that is they didn't have that software when they did Toy Story. And their camera person, Sharon Callahan, had the amazing ability to be able to look on the screen, see that color, and know what it's going to end up on film. So she was doing that transformation in her head. So she would adjust on the screen so she would get the color that she wanted on film. This obviously was not a tenable thing for to train people to do that. That was
doesn't scale very well.
And it's not scale very well at all. So while they were working on A Bug's Life, I came in and put together a system that they could use to actually have it happen automatically and get the right colors in.
Are there any instances, little Easter eggs, where someone would look at that early film and go, "Oh, the color's wrong there"? Probably you're the only one.
Yeah, Sharon probably would.
Yeah, right. Is there anything else you want to say about color matching? I think we have.
I think that's pretty much what we work there.
And you mentioned Bug's Life, so I think that's the next major project they had there.
Yeah, Bug's Life was actually was in '98. I went back to Pixar. This is after I'd done the color stuff just before then. This was when I think that was the year that Bug's Life came out. I went back just after Bug's Life came out. So, and they'd spent quite a few years doing that. At the same time that they were doing Bug's Life, they also were doing Toy Story 2. And the original idea of Toy Story 2 was it was going to be kind of a cheap knockoff, just kind of, it wasn't kind of considered and I think they might have even been doing it I don't know if it was going to be TV or not, but it wasn't, it was sort of like all of a sudden now we had the A team and the B team. And at some point, Ed said, "This is not good for a company to do that." So after A Bug's Life came out, they corrected that, turned Toy Story 2 into a full-scale, feature animation, and put John in charge of it, because this poor guy, though, I mean, he just done two films in a row, and now they're here, and this has to be done in a year. Is the other thing that was sort of like a madhouse. But
oh my gosh, what drives those aggressive timelines, by the way? Because you mentioned in an earlier interview, they're much stricter than they used to be. I guess there's more moving parts now.
Oh yeah, and well, with any feature, the timeline, there's a deadline that you just can't not meet. because there's all the merchandise that goes on. There's all the advertising, the promotion. There are just so many different, long processes that all have to converge at the same point in time. And so, you just don't miss those deadlines.
Right. What was the work? Two questions. One is, what was the work, the culture like? And related to that, how much overtime did people have to work to get the job done? Did they have to work like demons to get these movies out? Or, yeah.
Which one was it? I think it was Toy Story 2. There was because it had the shortest. They revamped the whole movie like a year before it was supposed to come out, and changed a lot of the stuff. So that was the one that was really the hardest to get done. A lot of overtime was done to the point that there were a lot of people injured with repetitive stress stuff, and I believe our workman's comp insurance rates were starting to go through the roof, and so not a monetary thing, but also from a human level is that we can't do this. And so it was after that film that they became very strict about you don't do overtime unless you get approval for it, and you have to there has to be a good reason. So they really started to look into that quite a bit to rein that in. Right,
and not, as you say, not just for financial reasons, but for humanitarian reasons. Yeah. Can you tell us about the Xenon project?
Oh, okay. That was okay. So when I came back to Pixar, so this would have been in '98. At the time, it was still, there's an issue of how do you look at your animation in real time, or get a feel for it playing back. And at that time, they were using some sort of video equipment that Silicon Graphics was selling, and essentially you could send it sequential video frames. So they would, onto this box, and then it would play back the image in real time, the film in real time. It was a really flaky device. I can't even remember what the name of it was now.
Was it called something Central, like Movie Central?
That doesn't sound.
It's not a video server.
It's sort of, but it certainly didn't have that capacity to, it couldn't store a lot of video. But that was the general idea. You could send it individual frames, and it would play them back. So when I came on, they wanted to, have a newer version of that, something playback device for their animation, and that was what Xenon was. And so, interestingly enough, we ended up using a Windows box as the computer that drove it. So that the heart of the Xenons were Windows boxes. I can remember it being kind of unusual that I was responsible for Steve Jobs writing out this huge purchase order for a bunch of Windows boxes instead of Macintoshes. But he was always very good about that. He says, use Macs if they make sense. If they don't make sense, don't use them. Use something else. So at that time, we were all using Sun boxes, I think, and there were a few Macs around, but they were not really in the production pipeline at all.
Right.
So yeah, the Xenon was essentially allowed us to ship frames over onto that box and play them back. The interesting thing about it was that we could then start playing around with how they got played back. So it wasn't just a straight, play it back at speed. We could also then start doing things like, we'll give the animators the option that as they're looking at it, say, I want this part of it to be a little slower, a little faster. So you could go in there and kind of interactively play around with the timing of it, which was the first time they were able to do that. There was also using that thing called an exposure sheet, again, having to be able to do with the timing. So, it would almost do keyframes, and then allow them to shuffle, really play around with the timing on that. So, yeah, that did open up, some new things that they weren't able to do before, but also just did playback.
How many of Pixar's tools were developed in-house?
Oh, almost all. Yeah, it was all proprietary. And very little of it went out. The only, RenderMan was sold, but our animation system was never sold outside. It was always in-house.
Yeah, that's your golden goose.
Yeah.
Well, that's wonderful. And then the rest of your career, you worked in the tools group.
Yeah.
At Pixar. And what kind of changes did you see over the course of either the second Pixar incarnation or from the beginning to now?
Yeah, one of the things I noticed, I was in the tools group and I was doing a lot of support for the animators. So I was working on that animation system and had a lot of interaction with them. And when I first went back, I really felt that we were kind of all working together, and I knew them all, and I could wander out, go into dailies, and that was all great fun. As time went on, and we were doing trying to get a production every year, and then 3 every 2 years, the group, it grew, and to the point where by the end of that term, the interface between tools and animation were kind of formalized. We had certain people that kind of watched out for that, and it wasn't quite as chummy. But then the company now had over 1,000 people in it too, so it's like,
wow.
It's
what was the period when they really spun up in terms of headcount? Was that for Bug's Life or Toy Story, maybe?
No, it would have been sometime after Bug's Life and Toy Story 2, because they realized that doing a movie every few years wasn't going to make it, and they really needed to be able to. First, the goal was to do a movie a year, and so they were really starting to, and because these films take about 3 or 4 years from inception to finished film. So if you're doing a movie a year, that means you've got to have like 3 or 4 movies in production at the same time, and so that brings the head count up quite a bit. Of course, you need different people for different phases of that process, but it really does. You need to ramp up for that.
The process, how would you describe it, comparing it to those cell animators at NYIT and, the differences? I mean, they still use animators, I think, for some animations. I think The Simpsons is an example.
Oh, yeah.
Yeah.
Well, other than the animation, the process is very similar in that the original scripting and storyboarding and that whole pre-production phase is very much the way Disney did it for ages. It's so the process is you start out with you have a script written, and then people start doing storyboards, which look very much like Sunday comics panels, kind of telling the story. So from this happens and then this happens and then this happens. They will then record that on film and hold those frames for the appropriate amount of time, and do scratch recordings of voices and music. And you can actually then go into, before any animator has done any animation, you can go in and actually see what the film's going to look like. And they do a lot of work in that stage because the animation is very expensive. So if you're going to make changes, you want to make changes back in the storyboard phase.
Right.
And those techniques are pretty much as they've always been. It's just once you start to get into the animation phases that it becomes computer graphics.
Mm-hmm. Well, I think is there anything else, any questions that I haven't asked you today that you'd like to leave Any thoughts, parting thoughts about your career or the industry, you know, this amazing ride that you've been on?
Yeah. It's going to be interesting to see what happens when COVID is behind us. Because right now, Pixar they've all been working from home since last March.
Oh, wow.
I would assume there's some systems people and that around, but I'd be curious to see if you know, the gang gets back together again and all go to the same campus on a daily basis, which will be interesting to see how that works out.
Interesting. What are your feelings about the necessity of people being there in terms of, you know, just not feeling isolated either, but just having a collegial atmosphere?
Yes. And in fact, that's another interesting thing about Steve. When we, back in the early 2000s, we built the campus in Emeryville, and Steve was very much involved in designing the main building. And one of the things that he insisted on, or was the design idea, was there's a huge atrium in the middle where the cafe is there, the mailboxes are there, the restrooms are there. And the concept was you needed to get people out of their office and running into each other in the atrium and having serendipitous conversations. And so that's going to be a change somehow. People are not in the same physical place.
Yeah, I thought actually most of the work they do would be dependent on some fairly high-powered hardware or specialized equipment, but maybe not.
They can access it remotely.
Okay.
There are a lot of computers that are in the building that they're using, but they can do it remotely.
And like a good, fast home computer is good enough nowadays for them to do their work, I guess.
Yeah. That was another interesting thing. I don't know if I'm going to get the numbers right, but one of the things about computing power is how long it takes to render a single frame of one of our movies. And I think for Toy Story, each frame was on average, I'm probably going to get this wrong, but it was on average like 4 or 5 hours to do a single frame.
Oh my gosh.
And in the subsequent years, the power of the hardware has gone up, exponentially. It's like, 100,000 times probably more powerful now than it was back in Toy Story day. And today it takes about 5 hours to do a frame. It turns out that it's not how long, the limiting factor is turnaround, as to how much time can you allow the frame to last, because you're going to need to see that frame, like at most the next day. So all this extra computing power has not been used to speed up the rendering, but to make the rendering more complex. So the elements that are in one frame now is just, has gone up with the power of the computers. So it's kind of fascinating that it's, all of this increase, but it hasn't changed how long it takes to do a frame.
Right, and you're saying that's because the scene
complexity is now just,
has gone through the roof. There's so many elements, and yeah. Cool.